So, hey everyone, our project is Enhanced Indexing Strategies for SQLite, its implementation and evaluation. Uh, so coming to the intro of the project, as I mentioned, the title specifies we did implemented two new strategies for SQLite, which are GIN and BRIN, block range indexing and generalized inverted index. And yeah, we did implemented these two indexes in SQLite and performed some tests on these techniques. Yeah, coming to SQLite, what is SQLite? Similar to Postgres, SQLite is also widely used RDBMS, known for its lightweight design. It is self-contained and it doesn't require the server as it stores the data locally in the disk. It also offers transaction capabilities like either to commit for all or to none, which maintains consistency. Just like any other RDBMS, you can perform queries for data manipulation and query functions. Yep. This is the indexing which we implemented. The one is BRIN. Block range index is an index used in large data sets with structured or ordered data, where we apply this index on an attribute. Then it creates another table with ranges by storing the maximum and minimum value of that range, and references to these ranges blocks in the original data set. As you can see in the image here, these ranges store the references of the blocks from the original data set. This index saves a lot of querying time, and this BRIN index needs smaller storage space compared to the traditional B-tree index in SQLite. Coming to GIN, GIN is also a useful index technique for tables having columns, which stores array or big texts. When GIN is applied on this type of columns with arrays or big texts, then it analyzes all the data in the columns and forms a table with all the unique words from the text as keys and stores the references to the rows which has these words in the text for that column. Yeah. We can implement any kind of new features in SQLite by extensions. Extensions are like dynamic loadable modules which can expand SQLite's core capabilities. We can create extensions with following SQLite framework by implementing required functions. Once we create them, we have to compile them into shared libraries like .dll for Windows, .os for Unix. Once we compile these extensions, then we have to load these extensions by using proper commands like .load or SQLite 3 load extension function, as it mentioned here. And once we load these functions into the SQLite, we can use the functionalities we specified in this extension in the SQLite database environment. Yeah, from here on, one of my team member will continue.
Hi everyone, this is Inamullah. So coming to the proposed work, as we already mentioned, we are implementing BRIN and GIN indexes as a loadable extensions, which are nothing but DLL files. So DLL stands for Dynamic Link Library. So this DLL file basically serves as a bridge between SQL database engine and the application that wish to utilize its capabilities. So if you look at the image here, this is how a DLL is compiled. You basically have to give a .c file as an input, and it will output the DLL file and .lib and .exp files as well, which are nothing but they contain information about libraries that are required for the DLL file. Next. Next. So coming to the GIN implementation. So due to architectural limitations, GIN indexing was simulated using tables. Since we don't have composite data structures in SQLite, we had to take this approach. We created a table that has the following schema. Term is nothing but the key value, and row ID stores the row ID of the records that contain this key value. On top of this table, we created a B tree index on the column term. So we basically implemented 4 functions, one for creating index, another for querying, and the gene after changes will update the index after either inserting a row or updating a row, and gene after delete will update the index whenever a row is deleted. So these are all user defined functions and are not integrated with our query planner, so we have to invoke them manually. Next. So for the testing and evaluation of a gene index, we used a movie database. So it has around 10,000 records. So the scheme of this, it has 5 columns: movie ID, movie name, movie genre, movie plot, and director. So movie ID is the primary key. So all of these 5 are strings. So we basically applied index on the movie genre, which has comma separated values. So now to create an index, we use the function gene create index. So we have to pass the table name, column name, and the delimiter as well. So we know that movie genre is comma separated. So we send comma as the delimiter. So it returns 0, which means it is successfully executed. So it took about 199 seconds of time. And as you can see here, it also created the movie data gene summary, which is nothing but our index table. Next. And now querying the index is basically simple. We use the function gene query index and pass the table name in the search key. Then it will return all the rows that contain this search key in their movie genre column, as we created index on that specific column. And now I saved this output to a text file gene OP. So if you look at this text file, I just printed the top 2 rows. We can see that the movie genre of these rows has action in them. That's the reason they were returned. Next. And now, since we have to invoke manually whenever we insert or update a new record, we need to fetch row ID of the record inserted or updated. Here I inserted a record and fetched its row ID, which is 10,001. And I invoke the function gene after changes with table name, column name, and this row ID and the delimiter as well. So it returns 0, which means it executed successfully. And similarly, when we delete a record, you need to know the row ID of the record you're going to delete. So we did manually here, but they should be triggered automatically whenever some change occurs in the table. So for that, we need these to integrate with a query planner. We tried to simulate this using triggers, but it looks like you can't invoke a user-defined function in triggers if it is modifying any tables. So that's the reason we haven't implemented it. And now Akhila will continue with the BRIN implementation.
Hello everyone, this is Akhila and I'm going to explain about BRIN implementation. So BRIN is basically helpful when there is a range queries for large databases. For this project, we implemented 3 functions: BRIN create index, BRIN query index, and BRIN update index. So create index is helpful to create a BRIN index on a specific column, and query index is helpful to query the created index, and update index is helpful to update the index. Let's say if you are inserting a new row, then the index gets regenerated with the new data. And as my friend said earlier, once we are done with coding, we need to compile it into a DLL file. And once the DLL file was compiled, it was loaded into the SQLite. And to check the working of BRIN implementation, we used a COVID data. It contains 2 columns. One is date and the other one is world. Date is date, and the world contains the total number of COVID cases for a respective date. So as these are user-defined functions, these needs to be invoked manually. And in this table, BRIN index was created on column date. Next slide, please. Next. So we tested using this COVID table, and this table has around 2000 rows. So for creating a BRIN index, BRIN create index function was used, and as you can see here, the parameters are, one is the table name and the column on which we want to create a BRIN index, and the other is the block size. So once this was created in the tables, you can see one more new table, which is COVID underscore BRIN underscore summary. And this table contains the summary information of the COVID table. It contains it contains the minimum and maximum values of each block along with block ID. And on successful execution, the BRIN create index returns 0. Next. So this is the summary table which we discussed earlier. So first one is the block ID, second one is the minimum value for that block, and third one is the maximum value for that block. So for this, there are around 11 blocks, and yeah, this table contains the minimum and maximum values. Next. And to query a BRIN index, we need to use BRIN query index function. So it takes parameters like the table and the column and the condition to query. So this is an example, and so this returns all the rows between 2021 6/4 to 2021 11/20. And the time taken for this is 0.004 seconds. So to compare it with inbuilt indexing of SQLite, we used B-tree index, and we also applied B-tree index on date column to see the performance of BRIN index compared with B-tree index. Yeah, next. Yeah, from here on, one of my teammates will continue.
Hi again. So yeah, coming to the results of BRIN, after applying BRIN index on the data column of COVID data, on the date column of the COVID data, the retrieval, here are the results of retrieval query and the creation time for B-tree index, BRIN index, and without index on the COVID data. So yeah, when you see the creation time of the BRIN and B-tree index, the B-tree is creating in a short time compared to the BRIN, where BRIN is taking a bit longer compared to B-tree. But coming to the querying, extraction querying time, as you can see here, BRIN is outperforming B-tree amazingly. BRIN is just taking 0.004 seconds compared to without index and B-tree. So yeah, and when it comes to the GIN, well, similarly, after applying the GIN on the movie genre, which is a text column that stores related categories that movie falls in, as you observe here, the creation time of GIN takes too long, and even the retrieval time is taking a long time compared to B-tree. So by this, we can conclude block range index offers good efficiency with querying performance with larger data sets, the larger data sets which are naturally ordered. And on the other hand, GIN is taking long for both creation and querying time. So we can say by using BRIN in SQLite, we can make the query time good and efficient. By using GIN, GIN is not fit for SQLite. From here, future work will be mentioned by Inamullah.
Hi again, everyone. So coming to the future work, as index creation is taking more time, especially for GIN, we can explore more optimized text parsing and tokenization methods to reduce that time. And we can also try to integrate these indexes with the query planner for automatic execution, which meaning that we don't have to invoke them manually. And also we can use very large data sets for benchmarking and testing, which could provide deeper insights into the conditions under which each type of index performs better. And now let's dive into the live demo. So let me just quickly share my screen. So here we are. So first we have to compile the .c files to create a DLL. So now this is the command. So here it mentioned that gin is .dll is created. Now we need to open the SQLite database. Now first, let us see if how many tables. So we just have movie data table. If we just check the top row in it, this is the movie ID, and then we have the movie name and movie genre, the movie plot, and the director. So now first let us load the extension gin.dll into the SQLite. Now it is loaded successfully. So let us switch on the timer so as to track the time taken by each. So let us first create our index. So here gin create index function is called. We have to call it manually. So it's going to take a little bit time. I'm going to skip ahead of you. Now here you can see it took 186 seconds. And now if you want to query the index, we have to call the gin query index. So I'm searching for all the movies that has comedy genre in it. So see, we got a lot of movies. And now let us insert a record and then check how to invoke the after changes and after delete. So I have inserted a record, inserting. And now, so since we inserted a record, we need to know the row ID of the inserted record to invoke the gin after changes. So here's how you can do that. So the last inserted row ID is 10,001. Now here we invoked this function. So 0 means it executed successfully. And now for the deletion, let us delete the same exact record. So we're deleting. And then after delete, we have to also update the index after deletion, just like this. So 0, which means it executed successfully. And now Akhila will talk about the BRIN implementation. She will show you a live demo.
Hello again. So I'm going to explain about BRIN implementation. I have my code written in BRIN.c file. So now we need to compile it for the creation of DLL file. So this is the command I'm using to create the DLL file. Here we need to specify the location of SQLite and also the BRIN file. So .dll file was created successfully. Now we need to go to SQLite terminal and load BRIN.dll file. So SQLite. Now first we need to load this BRIN.dll file. It is loaded successfully. So you can see there are no tables for now. So I am creating a table COVID. And these are the two columns. So I need to import data from the CSV to this table. So there is a command to do that. And I'm importing the data from newcases.csv to this COVID table. If we can see now, this is the first 6 rows from the COVID table. We don't need the first row. So I'm deleting that one. We run the command again. So these are the first 6 rows from COVID table. Now I am enabling the timer, and now let's create a BRIN index on a date column. So here the BRIN index was created successfully, and to query the BRIN index, so let's see the tables now. There is a new table called COVID_BRIN_summary. This table contains the summary about this created BRIN index. Let's see the table. Yeah. So first one is the row ID. First one is the block ID, and the second one is the minimum value for that block, and third one is the maximum value for that block. And now let's query the created BRIN index. So here I am selecting all the rows between this given date range using BRIN index, and it is taking a very less time, as you can see it here. But using the B-tree index, it is taking more time compared to the BRIN index. Yeah, that's all. Thank you.